Good morning, everybody. Welcome to today's webinar, a joint webinar between CPFD and Tecplot. In today's webinar, we're going to be introducing Tecplot for Barracuda, which is a joint project between Tecplot and CPFD to give CPFD users or Barracuda Virtual Reactor users access to the power of Tecplot 360. So today we have a couple of presenters, myself, Scott Fowler. I'm with the Tecplot company. I'm the Tecplot 360 product manager. I've been with Tecplot since 1999, filling roles such as software development, product design, and now product management. If you have any questions about Tecplot or need a new feature in the product, I'm the guy that you want to come to. Then on the CPFD side, we have Sam Clark. He's a chemical engineer who's been at CPFD since 2008. He's an expert at modeling multi-phase gas particle systems with Barracuda Virtual Reactor. He's worked on projects for modeling a wide range of industrial processes, including coal gasification, chemical looping combustion, polyethylene production, and FCC regenerator systems. He also provides engineering support to Barracuda users worldwide and is an instructor in Barracuda training classes. So just a few notes about this webinar before we get started in full. We do ask you to participate in our, there is a question panel that you use and you can type in your questions. We do have online, but are muted. A couple other representatives from CPFD, Dr. who's the Chief Technical Officer, and Peter Blazer, who's the VP of Engineering Services, available to help answer questions today. So please use that question panel. If we don't get to your question right away, we will try to get to it at the end when we have an open question and answer session. This webinar is also being recorded, and we will send out an email within a couple of days, and we'll also get it posted on both the Tecplot and CPFD websites. So just quickly, today's agenda, we're going to give brief introductions to both Tecplot Incorporated and CPFD, the companies, just in case you're coming from one side of the user group or the other, and we'll let you know a little bit about our companies. Sam is then really going to take over from there, and he's going to let us know about CPFD and Barracuda Virtual Reactor. He's then going to go through a fluidized bed example from Barracuda Virtual Reactor and showing how it will work in Tecplot for Barracuda. And then we'll finalize the webinar with where you can learn more. So we'll give you some links, some emails, and we'll open it up for questions and answers. So a little bit about Tecplot, the company. We were founded in 1981 by a couple of Boeing engineers who originally started writing CFD codes, and they needed a way to visualize their results. So they hired a developer who's still at Tecplot today to write Tecplot. So we still have Mr. Tecplot with us and going strong with 47,000 customers worldwide. We're known as the most complete desktop post-processing solution. Tecplot has the ability to render beautiful 3D plots like you see right on this slide, but we can also get into the more quantitative plots with line plotting and 2D contour plotting. And we are dedicated to saving engineers time. That comes from not only the way that we process data, but our UX design team works on reducing mouse clicks, and we also have some nice ways to automate Tecplot through macros and Python. So we are dedicated to solving the big problems in CFD, post-processing large heterogeneous data sets. This example here shows a representation of our sizzle file format, which loads less data, which saves you time and saves you RAM, because loading data off disk is one of the most time-consuming parts of post-processing. We've also developed a solution called Tecplot Chorus, which comes with the fully paid version of Tecplot 360. This tool allows you to understand ensembles of data. If you're doing design of experiments, this is a great tool that you may want to look into. And then automation. We have a macro language that comes with Tecplot 360, and we also have, in recent years, the last 3 years, have had a very full-featured Python API that has really opened up the doors for much more advanced post-processing capabilities and post-processing analysis. Okay, and with that, I'm going to now hand it over to Sam to let us know a little bit about CPFD and take over the rest of the presentation. So Sam, here I'm going to make you the presenter.
Okay, great. Thank you, Scott. I am sharing my screen now, so hopefully that's coming through for everyone. Yeah, so thanks for the introduction, Scott. My name is Sam Clark. I'm with CPFD. And as a company, CPFD Software is a group of scientists and engineers and mathematicians, and we are experts in fluid particle systems and simulation. And our product is Barracuda Virtual Reactor. It is a specialized CFD code that simulates chemical reactors. And so, as we can see on this example over here on the right, and this is actually the example we'll use for the webinar demo today, Barracuda simulates the hydrodynamics of particles flowing around inside of chemical reactors. That's that left view. The center view is showing gas temperature, and then the right view is showing mole fraction of CO, which is a product from the reactions in that vessel. So Barracuda handles all three of those tightly coupled together: hydrodynamics, thermal, and chemical reactions. Our users, they use Barracuda Virtual Reactor to assess the performance of their systems through simulation. And so if there's an underperformance problem, they use Barracuda to try to determine the root cause of that underperformance. And then they reduce the risk of changes to a system through virtual testing. So if they are considering new hardware to put into their system or some other configuration change, they can explore that on the computer before implementing it. And then finally, people use Barracuda to identify optimization opportunities within their reactors. We deploy Barracuda through software licensing, application support, and simulation services. A quick note about Tecplot for Barracuda. Here at CPFD, we're very excited about this partnership and the capabilities of Tecplot for Barracuda. And just so everyone knows on the call, Tecplot for Barracuda will be our bundled and default post-processor for our upcoming version 20 release of Virtual Reactor. So we're really excited about that, and it's going to be a great tool for all of our users. We will be providing support for our users as they learn to use Tecplot for Barracuda and analyze their data. So if you have questions, contact us first at the typical CPFD support email or phone numbers. And if we run into anything that we need more help on, we'll always pull in the Tecplot team. But in terms of analyzing Barracuda results, we are the first line support crew for that. Okay, a quick overview of the example problem we're going to be using to do this demo today. This is a large industrial scale fluidized catalytic cracking regenerator, and Barracuda is very strong in this area. It's kind of become an industry standard for people who are doing simulations of FCC regenerators. This particular example is based on a case study that was presented at the 2016 AFPM annual meeting. And so there's a paper available if someone wants to dig into more of the details of the case study itself and what the engineering conclusions were. That paper is available from the AFPM website, and we'll make sure to send everyone a real link to this so that you can get it if you want it. And then we also did a webinar that's available on CPFD's website that describes the case study itself. And really what we're going to do for the demo today is we're going to look at two configurations of this system. We'll consider a side inlet for the spent catalyst distributor as our base case, and then a center inlet for the spent cat as a comparative case so that we can show some of the capabilities of Tecplot for Barracuda. Okay, I think, oh yes, we have one more. So the outline for what we want to show today includes basically a wide range of looking at what our simulation setup is, what the results are, how to explore these in Tecplot for Barracuda. It's not meant to be so much of a how-to or a tutorial, but more of a tour of what it's going to look like for Barracuda users as they begin to use Tecplot for Barracuda to look at their simulation results. And then for anyone who's on the webinar and just not familiar with Barracuda from past experience, I'll try to point out a few things that make Barracuda unique among CFD codes as well. All right, so let's go ahead and get started. I'm going to drop out of PowerPoint here. And what you'll see, I have two Barracuda GUIs open here. One is for our base case, which is that spent cat inlet on the side. I have another one open for our center inlet case. And then I have just a couple of file browsers open. As we look at the demo, I'll copy a couple of files between the two cases. Yeah, so let's go ahead and get started. So one thing that I do want to highlight as we get going is just how we've integrated several things into the Barracuda GUI itself. And so the GUI is arranged such that you have a tree on the side, and if you walk through all of the steps in the tree, you will go from the beginning of your setup to the end and running it and post-processing it. And so let's just start at the beginning. If we look at the setup grid window, this is where users bring in their three-dimensional geometry as an STL file. You define a computational grid, you generate your grid, and then you want to examine it to make sure that it looks good, that it captures the geometry well. And so we've got a number of integrated buttons here to view the grid, view the CAD, and so forth. So I'm just going to go ahead and click on View Grid just so we can see. You click this, it brings up the Tecplot for Barracuda window, and it brings up the view that you have selected. So here, this is just a view of our computational grid itself. And so you can open any of those, it brings up the appropriate view. You can also use some of these shortcuts over here in the quick macro panel that correspond to those views that we just saw. So right now we're on grid. If I double click on transparent model, it'll switch to that view. CAD, we can compare the grid to the CAD, you know, these sorts of things. So there's no need to close the Tecplot GUI and reopen it. All of these views are available right there from the quick macro panel, which is nice and convenient. I'm going to go ahead and get out of there. The next point of integration that I wanted to point out is in the run window of Barracuda. So once the simulation has started and you want to verify the setup of your model, this is where you would do that. And so just as an example, I'm going to click View Boundary Conditions. This is a shortcut that lots of Barracuda users out there probably click on every day. And so in this view, you can view where are the boundary conditions applied on the model, where can fluid and or particles enter the system or leave the system, which walls are adiabatic or not adiabatic, depending on how you set up your model. And so here, we can see a number of things. And again, just in case people aren't familiar with Barracuda, I just wanted to point out a few things. These red ones are flow boundary conditions where we can specify mass flow rates into or out of the system. Some of these blue triangles here are representing injection points, where if you have a lot of air holes in an air grid or distributor, then these are great for representing that. Up here, we have some pressure boundary conditions on these cyclones. So these are places where we know the pressure. We're going to specify that in the model. And then these lines are representing BC connectors that can bring materials back from the cyclone inlet down to the dip leg, and we can specify efficiency or even grade efficiency by particle size, things like that. So within the Tecplot GUI, there are some really nice things that you can do here. There's a zone style dialog that provides a lot of flexibility here. So I'm just going to expand this a little bit so we can see what some of the names are and stuff. So we can see we have all of our boundary conditions here. We can enable or disable individual boundary conditions very easily. You can change the colors of the boundary conditions. You can do all sorts of things that can help you explain your simulation setup to any colleagues or customers that you're working with. So there's a lot of flexibility there to help you highlight how your model is set up. Again, we saw some other shortcuts back in the Barracuda GUI, but they are all here as well. So we're currently in the boundary conditions view. So within the quick macro panel, we can easily switch. We can view our flux planes. Flux planes are really nice too. You can turn on or off groups of flux planes. very easily. You can change their colors. In this case, we had 4 flux planes that cover different quadrants of the system. So if I want to make sure that those flux planes are positioned correctly, I can turn each one on or off individually and really check my setup in detail that way. The other thing here is data points. And so I'll just point these out. These are high frequency output data that's available from the simulation. And people use these to represent things like thermocouples or pressure taps. And so often you'll put these in your model exactly as you would have them in your physical system so that you can monitor exactly the same types of data from the model. And we'll be using a few of these as we show some plotting examples. There's a whole set of data points up here that are collecting high frequency temperature data. And that was one of the key metrics when we were doing this original project. And so I'll just highlight how we can look at the output data from those as we go along. Okay, so I'm going to close this. I'll go ahead and exit here just so we can go take one more look at the Barracuda GUI. Okay, so here in the post-run menu, this is the other location where there's a lot of pre-set up views where you can look at your results for the particle side of things, for the cell side of things, or for time average cell data. So let's go ahead and open one of these. I'm going to open particle volume fraction here. This is a common view that our users tend to use a lot. And one thing I want to point out here is when we bring this up, Tecplot opens one result file at first, but really it scans through all of our results in our current directory, and we can go to any point in time by using the solution time slider or the controls here, right? So if I drag this slider, I can go to any transient point in the simulation. If I click the play button, then Tecplot 360 starts reading through the data from that point on. And if I click this button, it'll just take me to the very end of my simulation, which in this case was set to 100 seconds. So just pointing that out, there's no need to manually load different time steps or open or close Tecplot to move between different time steps. The next thing I wanted to show was the concept of using frames. So currently what we're looking at here, I'm just going to click on this edge. This is a frame in Tecplot, and you can use multiple frames within the Tecplot 360 window, and this is very powerful. You can do a lot of nice things. So I just want to show that. I'm going to right click and copy this frame, and here I'm going to try pasting it twice, just using Control V. Okay, so I should have 3 copies of my frame there, and I'm going to try to tile these, and here we go. All right, so what we can see, right now we have 3 matching copies of this frame, and by default, the frames are independent, right? And sometimes you may want this. You may want to control each view independently. For the example I would like to link these frames together so that they all stay together in terms of their solution time and the plot view that's being used. So I'm going to go ahead and apply that to all the frames and then close this. And so now you can see if I zoom in or out or rotate the view, now all of these views are tied together. And so this makes a nice way of comparing multiple pieces of data in a nice way. And so here, to demonstrate this, what I'd like to do is I'm going to leave the first view as it is. Let's say that's particle volume fraction. And then the middle view, let's take a look at the gas temperature in the system. So I'm going to activate that just by clicking in there. And I am going to choose one of these shortcuts here in the quick macro panel. And there is cells by fluid temperature. And so in this case, the fluid in our system is a gas phase or a mixture of gases, really. And what I'd like to do here is show how we could get kind of a half view of the system. So this is something that's kind of common that Barracuda users want to do a lot. So here I'm going to go ahead and turn on an orientation axis so we can see where we are. And as you can see here, a lot of Tecplot is very GUI mouse driven, so it's quite easy to use. You know, click and drag things around the screen, double click on things, right click on things, things like that. So here, based on this orientation axis, I can see that I want to cut my vessel right about y = 0. Okay, so I'm going to go ahead and hide that one more time. And let's go ahead and use blanking to cut that vessel in half. So I'm going to say at Y, I'm going to hide everything that's less than 0.01 just to give myself a little bit more than 0. So I'm going to activate these, and there we go. We can see that our view has been cut in half. By default, we can see inside the vessel, and it's kind of a transparent view. So, there could be cases where this is exactly what you're going for. In my case, I would like to see what's happening on this plane where we cut this. So I'm going to go back to my zone style dialog, and let's go to surfaces, and I'm going to change it to exposed cell faces. So that puts this face here, and then I'm going to right click and I'm going to say I don't want any translucency. I'm just going to turn that off. Okay, so now we have a solid representation of the central plane of our vessel, and we can see the temperature profile on that plane. Okay, so the other thing I'd like to demonstrate is just a lot of controls that we have available for the color bar. And so one thing that I like to do is play with the top and bottom limits on the color bars just to bring out stronger color gradients, and then also change color maps. And so for fluid temperatures, a lot of times I like to use something that goes from like a dark blue to a dark red to represent cool regions versus hot regions. And then we can also use set levels to specify the minimum, maximum, and delta within our scale. So in this case, something like 900 to 1400 works pretty well, and I can do something like 50 degrees in between each level. Okay, so that really brings out some of these colors a little bit more strongly and gives me the kind of view that I'm going for in that case. Okay. The other thing I wanted to demonstrate is the use of slices. So Tecplot for Barracuda has a nice interface for creating multiple slices. So I'm going to go ahead and activate that view by clicking on it, and then I'm going to turn off my scatter layer, which is the particles. I'm going to turn on slices. By default, it gives me a slice in the X direction, and for the view I want, I'd rather have Z planes. So I'm going to switch it to that. And instead of one slice, I'm going to just say I want multiple slices. I want something like 10 slices here. Okay, so that creates a whole array of slices quite quickly. And then we can change the variable that we're coloring these by. So I'm going to double click on that color bar again. And instead of the I variable, let's say we want mole fraction of carbon monoxide. Okay, and so it switches the field that's being used. And then again, we can change our color map to something that we might think shows our data a little bit better. So I'll just use this one as an example that goes from kind of this light orange up to a darker red. And I'll set my levels to just capture it a little bit better, 0.01 to maybe 0.09 by 0.01. Okay, so I'll go ahead and close these guys. All right, and so, in this case, as we've seen, it's possible to make some very informative views all within one window of Tecplot for Barracuda, and we're not using any scripting, we're not using any tricky things. This is all just through the default controls that are available to us. So once you get a view you like, it's very easy to export this as a snapshot or an animation. So here for snapshots, if you want a still image that you could put into an email or a PowerPoint, you can use File, Export. You can choose any of these formats that you like, a number of other options as well, but very easy to take a single snapshot. In terms of animations, as we saw, I linked all these views together by their solution time. So if you make an animation, you can go into this details box. You can choose where the animation starts and stops in terms of the time steps that you have. You can skip time steps. When you export to a file, you can control the speed of the animation in terms of frames per second. There's a lot of options for video formats, and so you can have those, or you can export a sequence of images, and sometimes that's really useful to do as well, depending on exactly what you're going for. So quite easy to export animations from this. I made an animation previously just so we don't have to watch the data files being read from the disk. And so here's an animation of that view that we just created. So you can see all three views move in coordination with each other. All right, go ahead and get out of there. Okay. The other thing I wanted to point out is just the concept of layouts here. So in this case, we've got a view that we like, and let's say that we want to apply this same view to another set of results. And so that's where we can look at our second case. So here I'm going to do File, save my layout. Okay, so I'm in my side inlet case right now, and I'm just going to say that this is my 3-view layout. Okay, I'm going to go ahead and close the Tecplot for Barracuda window, and here let's get that layout file up at the top of our list, and I'll go ahead and copy it over to the center inlet case. So now from our center inlet GUI, we can start with any view that we want. We're going to override it with that layout anyways. Okay, so once that data is loaded, we can load that layout. And one thing I do want to point out is we do have another customization within Tecplot called Load Barracuda Data. So this allows you to load a 3D data set or a data file or a layout. And in this case, that's what we're going for. So let's load that layout. We're in the center inlet. Okay. I don't want to save my old one. That's just a temporary one. Okay. And we can see that it loads that view that we just created onto this new data set. So we can clearly see that cinder inlet for the spent cat, and that comes in at a lower temperature than the rest of the vessel. So that's a really nice way to just copy a view from one folder to another. The other thing you can do with frames is not just compare simulation results from a single simulation, but from multiple simulations side by side. So here, let's go ahead and show that. Let's say that we wanted to compare side inlet versus center inlet on fluid temperature. So I'm going to go ahead and activate this view, and let's use our Load Barracuda Data tool again. I'm going to load the 3D data set from that side inlet folder. And so here I can pick any Barracuda output file, and this loader knows that it should load the entire results set. And then I'm going to right click here. I'm going to say I'm going to save my frame style. I'll say my frame.sty. And then we can load that frame style onto this frame. Okay, so we have our side inlet geometry versus center inlet geometry. And of course, if we don't want this view anymore, we can just highlight it, hit the delete key, and then we have our two views together. And they're still linked together. If we progress through time or anything, the linking is still maintained. So that's a really nice way to get multi-view post-processing to compare multiple cases. Okay. The next thing I want to demonstrate is some XY plotting capabilities of Tecplot for Barracuda. So I'm going to go back to this side inlet case, and let's do this based on cells by fluid temperature. And again, our fluid in this case is a mixture of gases. So I'm going to go to the end of my simulation, and I'll stick with this view for now because this will show us a couple of nice things as we go through this process. So the first thing I want to show is Tecplot 360 has the ability to extract data from the three-dimensional simulation results in a nice way. So here I'm going to do data extract precise line. And in this case, I know my geometry goes from about 0 meters to 15 meters. And so I'm going to define a line right in the middle of my geometry along the z-axis. And I'm going to extract it from the volume. And I want, let's say, 50 points. Okay, so I'm going to click extract. And then we can see here a visualization of the points at which the data has been extracted for this time step. And just say okay and close that. And then let's create a new frame here. And we're going to put that data into this new frame. So in this case, this is an XY line, and we can choose as our zone these extracted points. So I'm going to do that. And let's say on our x-axis, I want fluid temperature. On the y-axis, I want the z position or the elevation. Okay, so that gives us a really nice, quick way to plot that profile versus height. What you'll see is these extracted points actually contain all of the data from all of the fields in the data set. So if I right click on this, I could choose other things as well. And one thing that I might want to choose is, let's say I wanted the time average fluid temperature instead of the instantaneous fluid temperature. We can do that. I can go over here and do a quick Control F to auto scale that. And so now we see the time average fluid temperature rather than the instantaneous value at the current time step. I'm going to double click on this. So there's a number of things you can do. You can customize your labels. So if I didn't want that axis just to say Z, I can do something like elevation in meters. And that puts that there. And there's lots of other customization you can do as well on the XY line plots. Okay. The other thing I wanted to show was plotting data from, excuse me, from files that are generated as Barracuda is running. So I'm going to create a new frame here, and let's use our Barracuda loader again. And let's load data from our transient data file that contains those temperature, high frequency temperature data. So here, this file is called trans.data. I'm going to open that. And so what we'll see is that Tecplot 360 loads in the data. By default, it plots column 1 versus column 2 from that original file. And if we right click on this, we can use our mapping style dialog. And here we have a full list of all of the points that were available in that file. And I happen to know that those 3 temperature points were up here at about a 50-foot elevation. So they are these ones. So I'm going to go ahead and enable them. I'm going to do a Control F here again to auto scale. And so now we have these 3 curves versus time as they were recorded in that transient data file. We can add a legend to this. So I'm going to do plot line legend. We can turn that on. We can see here, this is pulling the text from the map name. And so instead of this kind of complex text that's showing us exactly what the position is of each one, we can give them some more meaningful names, right? We could say something like Cyclone A, Cyclone B, Cyclone C. And so in our case, this is more meaningful to the end customer or end user that we were working with. And then of course we can change y-axis labels and all that sort of thing as well. So a lot of nice quick ways to plot data that's coming out of the Barracuda simulation. Okay, and I think those are all the things that I have time for, I believe, in the demo portion. But there were just a couple of other things I wanted to point out, and those were back in this PowerPoint, so I'm going to go ahead and bring that up. There are a few other capabilities that are definitely worth mentioning here. We looked at extracting data at a single point in time. Is also a single instance in time through a spatial distance. But it's also possible to extract data at a single point in time, or a single point in space over many time points. So excuse me, I'm confusing myself. So as we can see here in this middle view, what I've done is I clicked on this point in the vessel, and then Tecplot read the fluid temperature as the simulation progressed and created this plot, which has the time marker. And you can make a video here where they play together, and so it's a really nice presentation of that data. Another thing that it has some really strong capabilities for are stream traces. So the animation that's shown on the right, we selected a boundary condition, and then Tecplot 360 can draw stream traces to follow where the fluid from that boundary would travel. And then the other things I wanted to point out was Tecplot 360 has its own macro language, and so you can record macros in the GUI, you can play them back conveniently. You can also do scripting with Python. All of the things that I showed today are just available straight from the GUI interface of Tecplot, but there is a lot more power available if you need to do more advanced post-processing. And of course, a lot more features than we've been able to mention today. In terms of questions and support, as I said before, CPFD will provide support to our Barracuda users as they get started with Tecplot for Barracuda. And so, make sure to check out our webinars and our customer support site, where we have a lot of help articles, and then email us at support@cpfd-software.com or call us 9 a.m. to 5 p.m. Central Time if you have any questions for us. And so, yeah, at this point, I will hand it back over to Scott.
Great, thanks, Sam. Yeah, similar sort of thing off the webinar about resources. Tecplot does have quite a few resources on our website. You can see the links there for both webinars that we've done and tutorials. We do have technical support available both in the US and Europe. Our US staff is available 6:30 a.m. to 5 p.m. Pacific time. And our European staff, they're located in Germany and available regular business hours out there through those two email addresses. And feel free to email me at any time if you have any questions or suggestions. Our support staff is usually a little quicker to respond than I am, because there are more of them than there are of me. It looks like you all have been really busy asking questions, so we'll try to get through as many of these as possible today. So I'll be asking the questions, and Sam or Peter, we may have you guys chime in. I'll certainly answer a few myself. So first question here for Sam. How does licensing work when using Tecplot? Can I post-process one or more cases while another project is solving?
Oh, okay, sure. Yeah, so the way that Tecplot licensing will work with Barracuda is that if you have a current license to use Barracuda version 20, you will have unlimited Tecplot GUIs that you can have open. And so, yeah, basically you could be pre-processing, post-processing with as many Tecplot for Barracuda windows open as you need.
Okay. And then next question also for you, Sam. When is version 20 going to be released?
Oh, okay, yeah. We have been providing advanced copies to interested Barracuda users now, and so if there are any Barracuda users on the line that are interested in trying it out, feel free to contact us, and we'd be happy to send you a download link so you can try it out. Our hope is to officially release version 20 in the month of May. And so, yeah, we're doing that kind of preview release right now, let people give us some feedback, and then get that official release out in the next month.
Okay. I'll tackle the next question. It says, how many cut planes can be added in one view? So Tecplot 360 has the ability to do what we call 8 slice groups. Within each slice group, you can show multiple planes, but each of those planes is going to have the same normal direction. So you could have a set of an arbitrary set of, say, Y constant planes or Z constant planes like Sam showed in the webinar. You can also do arbitrary normal direction. So it's 8 slice groups, and then within each slice group you can have multiple within there. So it ends up being quite a few. Okay, another question for Sam, or maybe I'll have to take this one. Can I use Tecplot on my local machine and have access to the data on the remote CPFD machine? I think I should probably take this one. So Tecplot does not work in a client server type mode. So if your data is remote, you're going to have to be running Tecplot on that remote machine to have access to the data, or you're going to have otherwise have some sort of remote access to that file system. Most of the Tecplot users that I interact with either have a remote desktop types setup, or they have a mount to the file system where they have their simulation data. Sam, do you have anything to add there?
No, I don't. You're the expert in that one, Scott.
Okay, great. Okay, another question for Sam on performance here. It says, it seems to work really fast with all the particles displayed. How long did it take to load the 100 seconds? Seems to work really fast with, oh, same question, it got typed in there twice. So yeah, how long did it take to load with all the 100 seconds of your simulation data with all those particles?
Oh, okay, yeah. And so this is one of those things that will definitely be simulation dependent, right? It kind of depends on how many cells and how many particles you have going and how many results files you output. I was looking at this one yesterday just so I knew the statistics. This particular model has about 250,000 cells and something like 2 million computational particles. And if I open the full 100 seconds, the load time, I think, was something like 1 minute. I think it was on the order of about 1 minute for that simulation.
Okay. Yeah, I'll just add in here that the way Tecplot 360 works when loading data is we'll scan through all the data just to understand what data needs to be loaded, but we don't actually load the data until it's required. So if you're loading a large transient data set like this, we'll scan through all the data, but then we'll only load the actual data, say, for the first time step. And then as you advance to the next, we'll load the data. And as you advance to the next, you'll load data. And your performance is highly dependent on the speed of your disk, or if you're going across the network, the speed of your network, and what you're displaying. So in this case, Sam was showing the particles as a point type. If you're going to show over 2 million particles as spheres, things are going to slow down quite a bit because you're just asking that much more of a graphics card. So performance can be dependent on a lot of different factors. Another question for Sam here. GMV, which is what a lot of your users are used to for post-processing, only a particle slice view in X, Y, or Z direction, not in between. How about Tecplot? I'm not an expert on GMV, so I'm going to have you answer that with your background.
Oh, okay. So I think what the question is asking is, in GMV, you can only set subset limits normal to the primary axes or along the primary axes. And Scott, you would probably know this better than I do about Tecplot. Like, can you just set an arbitrary angle at which you want to do blanking, for example? I don't have enough experience with blanking yet myself to know if you can set any arbitrary direction for either blanking or slices.
So the slices that you showed multiple slices in the Z direction. They were constant Z. Those slices can be drawn in an arbitrary direction. So we do have that quite easily. The value blanking that you showed, I believe you showed a constant X or constant Y value for value blanking. If you did want to do something in an arbitrary direction, you'd have to compute a new variable, which represents the plane equation, and you could then blank in an arbitrary direction like that.
Oh, okay. Okay.
Okay, I'll take this one. Is it possible to generate an animation while turning, zooming, and moving the geometry? The answer is yes. So Tecplot 360 has built in a keyframe animation tool. So if you go to the animation main menu, you'll find an option to do keyframe animation. That will do panning and zooming. And you can also do rotation by setting up a number of keyframes. And we do a linear interpolation between each keyframe. If you want to do anything more sophisticated, you can then use our macro language to set up views. So you could, when I say more sophisticated, you could say animate slices while doing the turning and zooming as well. So a lot of capability there. Okay, geez, a lot of questions coming in. Let's see. How about another one for Sam? Is it possible to extract the raw data in another way? So you showed using the extract precise line. This user says that they use the GMV to TXT Python script a lot. I guess, is there an equivalent to that, or do you know how to answer that question?
Oh, okay. Again, I might need your help on this one, Scott. So GMV to text is a Python script that I wrote years ago that outputs the data in a column text format from Barracuda, and then you can like take that data into Python and do further analysis. I don't know if that's possible from Tecplot 360, but it also may not be as necessary, right? If I understand it correctly, with the Python scripting capabilities that Tecplot 360 has, it could be that we can do a lot of the numerical analysis that we tended to export into kind of raw Python scripts. Maybe we can do those more directly in Tecplot 360. Can you speak to that, Scott?
Yeah, sure. Yeah, after you do that extraction, you have the data in Tecplot, and there are a couple of ways you can get that out. You could certainly write the data to a file. We have a couple of ways to write data from Tecplot, so you can get it in a text format. And as Sam alluded to, we do have our Python API, so you can interact with the data directly in Tecplot 360 using Python. So we have some very nice APIs that will allow you to query the data live while it's in the Tecplot GUI to get that information out and do further analysis. So I think you have a lot of capability there. Okay, can we use Tecplot with old Barracuda? Can we use Tecplot with older Barracuda versions?
Okay, yeah, I'll speak to that. So the Tecplot launching functionality is only going to be available from version 20 onward. It wasn't built into the previous versions. However, if you have GMV files from older simulations, we are including a utility in the version 20 release that will allow you to convert those GMV files into a Tecplot format. And so you can post-process those older results using Tecplot. And so, yeah, there is that ability to use Tecplot for older simulation results.
Okay. There's another one. This might have to be answered jointly by us, Sam. Can you deselect certain particle species from a PVF view? For instance, look at only coal particle fraction without any catalyst.
Oh, okay. I think I know what's being asked. So PVF view, I think, is referring to particle volume fraction view. And so if you wanted to isolate one species, then you can use that blanking feature that I showed for creating a subset of the geometry. The same blanking feature can be applied to particle data. So you can blank all of your particles that don't meet your species criteria that you want, right? So you can select a certain species and then view just that one species.
Yeah, perfect. That's exactly how I would do it. It would be that value blanking feature that you showed for blanking out the geometry, but you just blank on a different variable, which is associated with the particles.
Right.
Okay, let's scan down here. What do you suggest for training or learning Tecplot for Barracuda? Have you guys developed any training materials other than this webinar yet, Sam?
So we are in the process here. We are hoping to generate some videos to help Barracuda users make that transition from GMV to Tecplot in the smoothest way possible. And so we will be getting those ready, and we might also do kind of a training class that is basically webinar style, right? That way all of our users can see a little bit more of a tutorial style, because this webinar was more showing just what is possible to do and how it interacts with Barracuda. And so we might try to do something else that's a little bit more hands-on, step-by-step for people who are using Barracuda every day to do this post-processing.
Okay. Another one about performance. I think we kind of answered this already. It depends, but the question is, how is the performance when creating an animation of transient simulation with material flow? And again, Sam, I think you already addressed this, that it really depends on the size of your grid, the number of particles, the type of hardware that you have. So it's a really hard one to give a definitive answer to.
Right, exactly. One thing that I can say, just for people out there who have been using GMV for a long time, what I've seen is that the the performance for generating an animation in Tecplot is about the same as what I saw with GMV, where you have to read the files from the disk anyways, and you just can't really get away from that. I've done a couple of tests between spinning hard disks and solid state drives, and the SSDs are definitely very, very fast. So again, just hardware dependent, and how fast can you read the data from the drive.
Mm-hmm. Great. This one is about platforms. Are there any special considerations for running VR20? I'm assuming that means Barracuda Virtual Reactor 20 with Tecplot on Linux. Have you done any testing on all or any of these operating systems, Red Hat, CentOS, SUSE Enterprise? I guess I'll handle the Tecplot side. So Tecplot, we do testing on Linux platforms. We do support Red Hat, CentOS, and we publish support for SUSE Linux Enterprise Desktop. We don't we don't specify support for SUSE Linux Enterprise Server. So there's SLED and SLES. But many of our users, Tecplot 360 users, do use SUSE Linux Enterprise Server, so it is known to work there. Any other considerations with BVR?
No, not really. I mean, Barracuda, the system requirements are not changing at all from past versions. So we support Windows 10 specifically, and also Linux. And so, we tend to test on CentOS and Ubuntu the most. And so those are definitely well supported, but there's no reason that it wouldn't work on other flavors of Linux either.
Yeah, I'll also chime in that Tecplot is also tested on Windows 10, and we also do have a Macintosh version supporting Mac 10, 13, 14, and 15. But I don't believe Tecplot for Barracuda is not going to be supported on Mac. Is that correct, Sam?
Right, that's correct. Yeah, currently we only build distributions of Barracuda for Windows and Linux.
Okay. Here's one that seems fairly specific to somebody coming from GMV. Will there be an equivalent to the batch movie script that will be able to change between attributes while making a video?
Oh, okay. So actually, yeah, this is related to something else that you said earlier, Scott. So I don't think that we'll have a need for a script that necessarily does this, but I think, as Scott described earlier, if you use the keyframe feature, that should get you the same sort of result, right? Where you can transition your view as the animation plays through time. So I think that keyframe feature is really going to be a nice feature that we can get to that same result, and probably in an easier way than our old batch movie abilities.
Okay. Let's see. Do the two calculations I want to compare need to have the same end time? Not exactly sure what's meant by this question. So Sam, maybe you can help me out here, but I'll just give a go at it. If in Tecplot 360 you saw Sam load two different results, one with a center inlet and one with a side inlet, those don't have to be they don't have to have the same solution times at all. They don't have to have the same start time or end time. But when you, at least in Tecplot, it might make sense for them to have the same start and end time for your case. But when you do the solution time linking between the two frames, they can be fairly independent, and Tecplot actually works pretty well with that scenario. We've made some specific decisions in Tecplot about how it deals with transient data or unsteady data to work with fluid structure interaction, and oftentimes those have different time step intervals as well. So I think you should be fine there. Anything to add or any insight there, Sam?
I don't think so, Scott. I think you're the expert on that one. So
yeah. Okay. Yeah. Okay. Is it possible to convert PLT, so that's a Tecplot format, to human readable format? So yeah, Tecplot PLT format is a binary format, and within Tecplot 360, you can go to the File menu and you can say Write Data, and that can export it to Tecplot's ASCII file format. We also have under the Tools menu the ability to write it out as comma separated values. The comma separated values only has the capability of writing out values that are at the nodes, though it doesn't write out values that are at the cell centers. So just be aware of that. Well, I think that's most of them. Let me just do another quick little scan here, Sam. We've got a lot of people still online, and it looks like a little bit of activity here. Is there a way to remove the black line in the time series plot? So Sam, you showed a time series plot that had a little black line moving. Yes, you can remove the black line. Unfortunately, there's no GUI way to do it in the GUI. So at this point, you have to do it through a macro command, but it is possible to remove that. And it's something that we should consider is moving a command into the GUI to be able to turn that on and off. Can Tecplot handle time averaging of data? Not directly, not built into the GUI. That's really the expertise of our Python scripting language at the moment, and we have some example Python scripts. If you just Google for Tecplot and GitHub, we have a time average Python script available, free open source. And if you have a question, any further questions on how to do the time averaging, I'd recommend contacting Tecplot technical support for that one. And Sam, I'll certainly work with you guys on making sure that you have access to those scripts.
Yeah, and one thing I wanted to mention, Scott, too, just while we have people on the line, I forgot to mention it when someone said, how do we learn how to use Tecplot? I do want to point out that these webinars and the videos that you guys have on the Tecplot website are really, really good. And there's a big library there about how to do a lot of things. So, as I've been learning myself, they've been super helpful. So I definitely recommend that videos library that's on the Tecplot website.
Okay, well, I think we may have got to all the questions. Let's just do one last scan here, see if any last minute ones have come in. Let's see, with Tecplot, if additional data are needed once the simulation is finished, is it possible to extract additional transient data? I'm not sure I quite understand the question. Sam, do you have any insight on that one?
Just one comment on it. I mean, there would not be any option to extract any data that you did not select in the Barracuda GUI as you were setting up the project, right? So if you just totally forgot to export a certain field of data, then it won't be there. But the transient data extraction is basically, this what I showed here, where you can put your mouse anywhere in the domain and you can extract data at the frequency of your output files for any field that's in the output. So yeah, maybe I think that might address that question. It is possible to extract things over the entire range of output files.
Okay. Well, there were a lot of questions that came in. If any of you asked a question and didn't get an answer or have additional questions, please use our contact info to reach out to us. So I do apologize if we missed anybody or didn't quite answer your question just right. It can be hard in these types of scenarios. So with that, I'll thank everybody for your time and your attention. Sam, great job on the webinar, and we really hope that you all get some good use out of Tecplot for Barracuda.
Yeah, thank you, Scott. I think it'll be really nice for all of our customers and users of Barracuda.
Great. Okay. Thank you very much. Bye-bye.
Thanks, everyone.